In this video, I'm going to describe the two test cases that are provided by LeetCode for the maximum path sum problem. Initially, in this particular tree, I have the null pointers that emerge from the nodes that are the leaves in the tree, and they all represent 0. As part of this, you can use computational thinking to think that once you reach a null pointer, that sum is going to be 0, and therefore there's potential for recursion. So now what's going to happen is we're going to move up the tree. We're going to say that at these particular nodes, we have leaf node 2 and leaf node 3, that those nodes by themselves have sums of 2 and 3. So right now, this particular leaf node is the winner. When we go up one level, we see that we have a subtree to the left and subtree to the right that contain a path for 2, 3, and then we sum them together and that becomes 6. The next tree that they provide gives a little more perspective about subtrees and what we have to consider when coming up with a solution. First, we start at all of the leaves. These nodes start with 15, 7, and 9. So right now, the node 15 by itself is the winner. When we move up one level, we have certain cases that we have to consider. What happens if this node by itself were to be the biggest value? Let's say if this was negative 15 and negative 7. Therefore, trying to come up with a path that's larger than 20 wouldn't be possible. So we have to consider that this scenario where this node is the largest could possibly be the case. Or let's say if I have 15 and negative 7, that this particular path is the case. Or if I have 20 and 7 and negative 15, that becomes 27. So we have a third case. But neither of these cases are presented in this particular test case. But what we do have is a valid path here, the next level, that we go to 42. And this path here is our most valid. So now we have to evaluate the next level. At the next level, we have 9 and negative 10, so this path by itself is negative 1. Which means that any path that comes through the root and goes this way is actually going to be reduced. So we have a path that's negative 1 and then 20 and 15, so that becomes 34. And then our next path would be negative 1, 20, and 7, which becomes 26. So we would have paths of negative 1, negative 10, 29 and negative 10 is going to be this path here. So that's going to be 19, 34 and 26. So none of the potentials based on where we're starting. And also if we start here, 10 and 20, negative 10 and 20, that's 10. So based on all of these potential cases, nothing beats 42. So we have to account for another scenario in which none of those values is the actual maximum path, that the maximum path is a subtree. So there are 4 different cases that we have to consider. And as you're going to see in the write-up, I'm going to talk about how most people when doing interview are going to miss this last case, the one that I have drawn here. For example, if I have 20 up here and we have some sort of other tree that I present an image of it, it will miss this. And so the cases that catch that 4th case will get missed in the interview. And we're going to discuss how to use computational thinking to catch that.